the first approach.
Alright, so in order to solve this limit, in order to find the exact solution for this limit, I'm going to show you two different approaches. The first approach, I'm going to use the limits of the number e. Remember, e is limit u approaches 0 of 1 plus u to the 1 over u. Here I use u because I want you to see x and u's are different. These two are two different variables. You see that? The reason why I think about this limit e is because I see this is a function with the base is a function of x and the exponent is also a function of x. So I think about limits of the number e. E is equal to limits 1 plus u to the 1 over u by definition. So now, in order to apply this limit into this limit, I have to rewrite the whole function inside the parentheses as 1 plus u. So let's see how I can do it here. I have 5x over 5x plus 3. I want to show up the form 1 plus u. So on the top, I'm going to show up 5 plus 3. So 5x plus 3 and then subtract 3 over 5x plus 3. You see that? Now 5 plus 3 over 5 plus 3 is 1 plus negative 3 over 5x plus 3. See that? Now I have show up the form 1 over u, right? That means I use this one as u, right? I use this one as u. You see it as u. So one thing you notice here is when x approaches infinity, you see that the denominator get larger and larger, right? So negative 3 over a large denominator should go to 0, right? Should go to 0. So let me rewrite this limit. So this equal to limit x approaches infinity of 1 plus negative 3 over 5x plus 3, the whole thing to the 2x. You see that? The whole thing to the 2x. Now I'm going to erase this one, okay? I'm going to erase this one. And I'm going to box this one. I want you to see this is number e. Let me box this one first so that we not going to be confused between these two. Alright, so here I'm a set. U is equal to, let me use the number, different color. U is equal to negative 3 over 5x plus 3. You see that? 5x plus 3. So what do we have here? I have two different things here. One is u approaches 0 as x approaches infinity. And the other thing, I can solve for x from this equation, right? From this, if I flip, I got 1 over u is equal to what? 5x plus 3 over negative 3, right? And then if I multiply both sides with negative 3, I have what? I have negative 3 over u is equal to 5x plus 3. And then solve for x, so if I subtract both sides by 3, I got this is 5x, right? And if I divide both sides by 5, I have negative 3. I have x here should be equal to what? X here should be equal to, if I divide both sides by 5, okay? If I divide both sides by 5. So I have negative 3 over 5u, right? Negative 3 over 5u minus 3/5. You see that? That's it how I solve for x from this equation. You see it? And let me color this one. This is u. You see it? This is u's. See that? Now I'm going to erase my work here. This is your basic college algebra. You solve u from this quotient equation, right? This is a rational function. Alright, I'm going to erase this part. Alright, so now what do we have? If I have x equal to here again, I have x is equal to negative 3 over 5 u minus 3 over 5. This equal to minus 3 over 5. Let me use this color. So this equal to what? This equal to negative 3/5 times 1 over u minus 3/5. And then I have 2x is equal to what? 2x is negative 6 over 5 times 1 over u minus 6 over 5. You see that? So here, what do we have here? I'm going to replace u in, I'm going to replace negative 3 over 5 plus 3 with u. And I'm going to replace 2x with the whole thing here. You see that? So here, what do we have? I'm going to move to this side. So this equal to limit, this is 1 plus u, right, 1 plus u to the what? Negative 6/5 times 1 over u. I'm gonna use u here as well, this is u, right. Minus 6 over 5, you see it, minus 6 over 5. And this is a function of u, so I'm gonna use u approaches 0. You see that? This is how I deal with this. Alright, so what do we have in here? I want to show up the from 1 plus u to the 1 over u, right? So I have to modify this exponent using the property of exponents. So let's see how I do it. This is equal to limit u approaches 0. And here I'm going to use a quotient 1 plus u to the negative 6/5 times 1 over u. Here I can use 1 over u. And it should be like 1 over u. Time with negative 6/5. And minus 6/5 here I have 1 plus u to the 6/5, right? To the 6/5. To the 6/5. To the 6/5. Remember, with the negative exponent, when you flip to the denominator, you change the sign. You see that? So this is what we have. We got so far. Now the next step. Can you see it? Let me check to make sure the bar show everything. All right. The next step. The next step. This is what? This is limit. I'm gonna use quotient rule. Okay. I'm gonna use quotient rule. So this equal to. I'm gonna make a quotient rule here. This is limit of 1 plus u raised to the 1 over u. The whole thing raised to the negative 6/5. And the bottom, and don't forget this u go to 0, right? U go to 0. And the bottom you have limit u approaches 0 of 1 plus u to the 6/5. Let me rewrite this one. 6/5. Can you see it? To the 6/5. Alright, so now what do we have? From here, I'm going to erase this part because it's no longer necessary. Right. Now from here, you see this limit 1 plus u to the 1 over u when u approaches 0. It should be the number e. You see, it should be e. Raised to the negative 6/5. And at the bottom I have what? 1 plus. For the bottom, you use direct substitution, right? 1 plus 0 to the 6/5, right? So what is this answer? This is equal to e to the negative 6/5. Here I'm going to use the color e here so that you know where I can get e from. And this is 1 to the 6/5, which is just 1. So the final answer here is e to the negative 6/5. You see that? This is the answer. This is negative. You see that? Alright, so that was the first approach. Now I'm going to show you the second approach. The second approach. In the second approach, I'm going to use the L'Hospital rule. Here I'm going to use L'Hospital rule. L'Hospital rule. L'Hospital rule is applied for indeterminate form, right? Here, if you use direct substitution, you have when x approaches infinity, 5x goes to infinity, 5 plus 3 goes to infinity, 2x goes to infinity. So you have infinity over infinity goes to infinity. This is indeterminate form. That's why we think about L'Hospital rule, right? Because L'Hospital rule is applied for indeterminate form. That's the indeterminate form, right? Indeterminate form. You see that? So let me recall the L'Hospital rule. I'm going to erase this one. The L'Hospital rule says that limit x approach infinity. Here I can use x approaching a or any number, but because we are dealing with limits at infinity, so I use limits x approach infinity of f of x over g of x. And is equal to what? Is equal to limits x approaching infinity of f prime of x over g prime of x. You see that? You see that? But the thing here is, if you notice, this is a function in the form f of x to the g of x, right? Because you have x in the denominator, you have x in the base, and you have x at the exponent. So you cannot use L'Hospital rule in here because you cannot differentiate the function in this form. Right? You have not learned how to differentiate it yet. So the first step we have to modify this function. So here I'm gonna use a couple tips. The first tip. If you have the function f of x, let me use different marker. This one doesn't work. If you have the function f of x raised to the g of x, you can use, remember that e to the natural log of a is equal to a, right? Because e is exponents with base e and natural log with base e. These two are the inverses. So e to the natural of a is a. So here I'm going to use this equal to, let me use black color. This equal to e, and e, remember e to the u, you can write exp of u. This is a different notation. So I'm going to use exp of natural log of f of x to the g of x. To the g of x. You see that? To the g of x. See that? And we use the exponent rule. So this equal to what? This equal to g of x is equal to exp of g of x natural log of, let me use different color here, natural log of f of x. And is equal to what? Is equal to exp of natural log of f of x over 1 over g of x. You see that? 1 over g of x. When you multiply a number, you basically divide it by the reciprocal, right? And now you have show up the quotient, right? In order to use L'Hospital rule, you have to show the quotient. Now you have the quotient, however, you stuck with the base e, right? So I want you to memorize one more tip. Tip 2. That is limits x approach infinity of e to the f of x is equal to e to the limit of f of x of g of x when x approach infinity. So this is the second limit. Limits of exponent is the exponent of the limit. See that? So we are going to use these two tips into this function. And you see here, if I apply the first tip, f of x is 5x over 5 plus 3, and g of x is 2x, right? So So this limit is equal to limit x approach infinity of this is exp, and I'm going to use the result right here. So I have natural log of f of x here is 5x over 5x plus 3. See that? And g of x is 2x, and this is 1 over g of x. So I have this is 1 over 2x. You see it? 1 over 2x. Right, 1 over 2x. Alright, so this equal to what? This equal to limit x approach to infinity of here I'm going to use the second tip. So I'm going to bring the exp outside. Exp of limit x approach to infinity of, here I have natural log of 5x over 5x plus 3 over, let me use the black color for this one, natural log of over 1 over 2 times 1 over x. You see it? 1 over 2 times 1 over x. See that? You see that? And now I'm going to set this as equal to e to the y. exp of, I'm going to set this y at y. Let me use different color for this. I'm going to set these at y. You see that? Yes, that's y. You see that? And y here, because I don't want to write the whole thing exp when I work on this problem. And y here is equal to y here is equal to limit x approaches infinity of natural log of 5x over 5x plus 3 over 1/2 times 1 over x. You see that? And I'm going to use a quotient here. You see that? This is y. See it? This is y. Right. So we want to find e of y. Let me rewrite this one. This is equal to what? This is equal to e to the y. Right. This is equal to e to the y. Right. E to the y. Where this is where y is this limit. You see it? That means I set the whole thing in the brackets as a new variable y. Right. Now I'm going to erase this board because we have finished all the tips. We don't need them anymore. I'm going to erase this. Okay, I'm going to erase this. So now we have to deal with the limits y. Right. Here we have what? Y is equal to, y is equal to, right, limit x approaches infinity of natural log of 5x over 5x plus 3 over 1 over 2 times 1 over x. Right. Now we use the L'Hopital rule for this function. So this is equal to limit x approach infinity. The foot rib of this one is what? The foot rib, first you have to remember that natural log of u, the derivative is equal to 1 over u times u prime. Right. 1 over u, first you have to flip the function. So you have 5x plus 3 over 5x. Right. And don't forget the foot rib of this one, which is 5x over 5x plus 3 derivative. Right. Derivative. Don't forget the derivative side. And the bottom here, when you find the foot rib, you have 1/2 times what? Negative 1 over x squared. You see that? Because 1 over x derivative is negative 1 over x squared. You see that? Now we have to deal with the foot rib of this quotient, this rational function. So this equal to what? This equal to limits x approaches infinity of, I'm going to use this quotient. Alright, so here I have 5x plus 3 over 5x. And the foot rib of this one, I have the denominator is 5x plus 3 whole square. The top of this is what? I have what? 5 times 5, I'm gonna write down here, okay? 5 times 5x plus 3 minus 5 times 5x, right? Over 5x plus 3 whole square by quotient rule, right? And 25x minus 25x is cancel out, so we got 15 in here, right? And the denominator is 5 plus 3 whole square. And the bottom here is what? The bottom here is 1/2 negative 1 over x squared. See that? Negative 1 over x squared. So here now we're going to cancel the term. So this is limit x approaches infinity. Can you see the board? X approach infinity of 5x plus 3 cancel with 5x plus 3. So we have 1 5x plus 3 at the denominator. Let me write down here. Here I have this is what? This is 3. The top become what? The top become 3 over x times 5x plus 3. And the bottom is 1/2 minus 1 over 2x squared, right? This is minus 1 over 2x squared, right? Minus 1 over 2x squared, right? So how do you deal with this limit? This limit, when x approaches infinity, what do you see in here? The top go to what? Let me show you this one. This equal to what? This equal to I have to erase this part to show you the next step. So remember this one is e to the y, okay? Let me erase here. This one is equal to e to the y. Let me erase this one, because I need to erase some part of the board. So I'm gonna have this equal to e to the y, right? And we are finding the y, right? E to the y. Now I'm gonna erase this board. So e to the y here is what? Is equal to, here I have first what is y? Y here, we continue here, okay? This is y. Y is equal to limit x approach infinity of, the top become what? The top become 3 over, the top is, now we have what? We have 3 over 15, 3 over 5x squared plus 3x times with the reciprocal of negative 1 over 2x is minus 2x squared, right? Minus 2x squared. You see that? And I'm gonna box this one together. You see that? So this equal to limit x approaches infinity of what? Of this is become what? Minus 6x squared over 5x squared plus 3x, right? And this limit is easy, right? You divide both numerator and denominator by x squared. So this is limit x approach infinity of minus 6 over 5 plus 2. This is minus 6 plus 3 over x squared, right? When x approach infinity, this one go to 0. So this go to negative 6, this go to 5. And the answer here is negative 6/5. You see that? So we have found out that y is equal to negative 6/5, right? So the answer here is what? The answer here is e to the negative 6/5. Let me color this one. Negative 6/5. You see that? So that's how you find this limit. So that's it. Thanks so much for watching my video. I hope you find my video helpful. See you next time. Bye bye. In general, limit x approaches infinity of ax over ax plus b, the whole thing to the cx, is equal to e to the negative bc over a. Alright, so that's it. Thanks so much for watching my video. Bye bye.